Hello, and welcome to this week's Ethical Dilemma in Science, where we're going to take a look at the single-use plastic bag bans that we're seeing coming more and more common around both the United States as well as the world. So if we take a look at it, again, looking at this in terms of a timely issue, over here we've got an article from the Irish Sun. The European Union banned plastic cups, plastic plates, and plastic cutlery as of July of 2021, and then more close to home, taking a look at New Jersey, the Philadelphia area, and Delaware, all of which are either implementing plastic bag bans in 2022, or in the case of Philadelphia, their ban went into effect as a soft ban in 2021. And now they're going to be enforcing it as of, I think it was April of 2022, so just relatively recently. And so basically, what is it that's going on? What is the issue with plastic and plastic bags, and why are they a concern? And so if we take a look at this, and just start out with just a quick YouTube video from The Graduate in 1967.
I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, sir.
Plastics.
Exactly how do you move?
There's a great future in plastics. Think about it. What do you think about it?
Yes, sir.
Enough said. That's a deal.
So what is going on with plastic? That movie was made in 1967. So roughly 55 years ago now at this point. And what we've seen over the last 50 so years, massive expansion of the plastic industry and the convenience and the use of plastics in basically every aspect of our lives. So to start out with, what are plastics? And so basically plastics are going to be materials that are able to kind of change change their kind of form in essence. They can start out as relatively soft material that can either be injected or shaped in some way, and then it's modified in a way that it becomes hardened and basically in a permanent shape. And so we've got a little bit of a GIF here kind of showing what's going on. So you've got kind of raw materials that are put into the hopper here. They drop into this kind of chamber that is going to heat it up. In the process of heating up these plastic pellets, in many cases, it's going to liquefy them. They're able to then inject that into a mold. And then when that cools down, that plastic that was formed within the mold will drop out as a hardened structure that can be used in some way. Okay, so if we get down to this, then what we're looking at is the fact that these plastics are going to be examples of polymers. And there are going to be lots of polymers that are found in nature. And so basically, when we're talking about a polymer, the term mer comes from meros in the Greek, meaning part or unit. And we're basically looking at a polymer for Greek for many, or mono, Greek for one. So when we've got a polymer, we're looking at something that has poly, many, mer parts. We're looking at something that has many parts. And so you can think about this almost as a chain. And so we've got a chain that's going to be present here. Each one of these individual little links is going to be an example of a monomer, mono for one, mer for part. And then when we hook together these links into the chain, we're going to get a long chain, which forms a long kind of sequence of these individual little subunits, making it into, in this case, a longer chain, making it into a polymer. And so if we take a look at this again from a natural perspective, lots of different examples of natural polymers in nature that have been used by humanity for many, many years. Examples of this are like animal horn, cellulose, latex. What I've got here on this slide is an example of a rubber ball created by the Mesoamericans, like the Aztecs, historically, 1,000 years ago, if not more. basically looking at the properties of the sap, the latex sap coming out of a rubber tree, and they're able to mold this into a rubber ball, which they were able to use in sporting events. Now, over time, we've tried to modify these natural polymers in some way to make them more durable, more usable in a variety of ways. And so again, using this rubber ball as an example, kind of natural rubber, and we can see it here, this is looking at the atomic structure, but you basically see kind of a chain that's going to be present, another chain that's going to be over here. This is natural rubber. This is the sap that comes out of a rubber tree. It's going to be relatively sticky and elastic, and then it forms that shape, but it can be softened when it's heated. And so it has properties that are kind of going back and forth. We can soften it, we can reshape it, and overall it has low tensile strength, low kind of stretching strength associated with it. Now, in the 1800s, Goodyear invented the process of vulcanization. And so vulcanized rubber uses these same polymers that are present in natural rubber, but what he did was add in sulfur groups here that are going to cross-link these chains. And in doing so, it changes the properties of these natural polymers. And so because of this, it becomes less sticky. It has the ability to kind of deform, so you can push on a rubber object, you can tug on a rubber band, and then it's going to revert back to its normal shape. Where the natural rubber ball over here could be soft when it was at a warmer temperature, the vulcanized rubber is stable over a much wider temperature range. And again, because of the cross-linking that's present, it has a much higher tensile strength. And so you can see something like vulcanized rubber being used in automobile tires. And so, the tire's not going to melt when you're, driving on a hot highway on a hot day. So it's stable. It has the ability to, kind of bounce around, to be deformed, but revert back to the shape that it was formed into. Again, having those properties that are beneficial for what was needed. Now, in the 1800s, there was an interest in finding more uses for these polymers. We've got animal horn over here. A good example of that is ivory. Ivory is a natural polymer produced by like African elephants, and it was kind of harvested at the cost of the elephant's life and used as a substance that could be kind of shaped or carved into something that could be used. But, there's a limited amount of elephants. The production of ivory is, relatively slow. And so there was interest in developing some kind of artificial polymers, some structures that would have the benefits of the natural polymers, but maybe some kind of added properties that are going to make them more usable. And, this is a little bit of a stretch, but I like this slide. It's a table that I actually got from a crafting website. And so we've got natural polymers that are going to be present. Over here, we've got cotton. Cotton has been used for years and years and years as a source of material for clothing. And so if you take a look at what's present within cotton, it's the purest form found in nature of cellulose. And cellulose is the most abundant polymer that is found in nature. But it has, some good properties. You get a cotton T-shirt. It's nice and soft. It, is absorbent. But if it gets too hot, you put your cotton shirt in the dryer at a high temperature, it's going to shrink down. It's going to change the shape again because the polymer is not stable in that form. Another example of a polymer down here, silk. Silk produced by insects and spiders as a natural polymer again that's often used for fabric, for threads, used kind of extensively in World War II for the creation of parachute, the canopies, basically the part that slows you down. But it's relatively hard to get because you got to harvest it from little silkworms that are going to be present, and they're only going to be producing a small amount at a time. And then finally over here, we've got wool. Wool is a very different type of polymer than cotton. Wool is actually a polymer of the protein keratin. So like if you have hair, the material that's going to be found within the hair. Different properties than cotton. It's going to be relatively durable, but if you take a look at it, if you got a nice wool sweater and it gets wet, it basically kind of loses its strength. It kind of stretches out kind of in every direction, and you've got to dry it flat or it's going to be kind of misshapen. And so natural polymers have a huge use. It's been used historically in lots of different ways, but there are properties that were limiting to that. And so from the 1800s going into the 1900s, there was this interest in developing new types of polymers, synthetic polymers that would have different properties. And so we see things like nylon and polyester and rayon as attempts to change the protein or change the makeup of these polymers to give them properties that were more beneficial for their use. So the first example of this is rayon. Rayon is a regenerated cellulose fiber. So you basically start here with those little cotton structures here. So you've got the cellulose that's going to be present here. You put it through a chemical reaction. So you clean it, you bleach it, and then you are basically going to kind of deform the chemical properties of the cellulose within this. You're going to take it from soluble fibers, convert it into an insoluble fiber, making it more resistant. And so you're not going to have the shrinkage that's going to be occurring with a cotton t-shirt if you're looking at kind of this altered rayon, this product, this polymer, in many cases a plastic, is a very simple form of plastic, as something that could then be used again because of the better properties for use. And so you see these kind of advertisements for rayon satin. It has a silky appearance without having to go back and finding, silkworms to produce the material that's needed. So there was a great search for synthetic plastics. It's very, very prominent within the late 19th, the early 20th century. And so we see things like the development of polystyrene over here, invented in 1929. And polystyrene is going to be an example of one of these plastic polymers that is going through a variety of bans. New York State is banning these takeout polystyrene clam takeout containers here because they're difficult to break down and they're a major pollutant. Polyester, an example of a fabric that's used in these plastics. Again, better properties than what we'd find with cotton and wool, more resistant in many ways. Over here, we've got polyvinyl chloride. This is a more rigid form of a polymer, more rigid form of a plastic. And so you can see this in PVC pipes, polyvinyl chloride pipes that are used in plumbing throughout a house. Polyethylene, invented in 1933, nylon relatively soon after that in 1935, and then finally a variation of polyethylene, polyethylene terephthalate, polyethylene terephthalate, PET, which we find often in the water bottles that the disposable water bottles that people use, was invented in 1941. So you can see lots of different examples of these synthetic polymers and different properties associated with that. And then, the benefits, the ability to use these different products in a whole variety of different ways. Now, in most cases, these synthetic plastics, these synthetic polymers, are created from either the byproducts of natural gas or crude oil. And so you're, kind of starting out here with these, fossil fuel type components. They're referred to as hydrocarbons. And they're going to be the raw material for most of these synthetics. And so they're going to be kind of altered in some way in order to create the plastic, in order to create the properties that are needed. Now, the problem with this is that if we take a look at this, from 1950 to 2015, there are about 8.3 billion tons of plastic that was going to be produced. A vast majority of this was used once, and then most of that is going to be discarded. And so, it's going to go into the trash. It's going to go into, landfills. It may get into a water supply, get into the oceans. A small portion of this is incinerated, and a much, much smaller portion of that is actually going to go through a process of recycling. And so what we can see is that very little of the plastic that is being formed is being reused in some way. A portion of it, stable plastics, the harder plastics in many cases, forming an object that has a much longer lifetime associated with it. They may, remain in use for a number of years. But we can see is these plastics are incredibly useful. We use them in packaging, building supplies like the PVC pipes, textiles like the clothing that we've talked about, as well as a whole variety of other uses. And so it's more resistant than something like glass. And so glass, made from silicon, made from sand, relatively fragile. Plexiglass or safety glass has these polymers that still give you the ability to look through a glass window or a glass-like window, but be much, much more resistant to breaking. So desirable properties associated with the plastics. And so if we take a look at this, what is the life cycle of these petroleum-based plastics, these synthetic plastics? They start out as a fossil fuel, either as crude oil or as natural gas. They are going to be converted into that resin, converted into kind of a liquid plastic that can be formed in some way. And then, for the most part, it is going to be disposed of, as we saw on that previous slide. Now, a small portion of that is going to go into a recycling process, and that recycling is basically going to kind of break it down into its constituent parts, its basic parts, and so that it can be reformed into a new plastic. But what we can see is that most types of recycled plastics are going to have a combination of recycled plastics and virgin plastic that's created anew. And over time, this continual cycle, this recycling of these plastic products, the chemicals within it, are gradually going to end up going to be contaminated in some way, less ability to recycle them in a pure form. And they're going to be what's referred to as downcycling. And so they're not going to be that high quality plastic that we'd want to use. It's going to be broken or used in a more impure form, more contaminated form, if you want to think about it like that. And so it's going to have less kind of usable properties for that. In some cases, it can be reused in the simple plastics formed for textiles, for clothing. But ultimately, what we can see is the vast majority of these plastics are going to end up being disposed in some way. So when we're talking about plastic bags and plastic bag bans, we're looking at two different types of plastics. The first are the high-density polyethylenes. And these are, if you look at a plastic object, this is a recycling code number 2, often abbreviated as HDPE for high-density polyethylene. We can see, a variety of uses for this. They can be in a relatively harder form, as you can see it for like milk jugs, containers in some cases, or because it is a fairly resistant form of plastic, you can see it being used in this case for a children's playhouse. They can also be used in plastic bags. Again, as the properties are going to be present, they have the ability then to, be relatively light, be relatively thin, and relatively strong. Now, in most cases, the harder plastics, these larger kind of plastic not the grocery bags, the milk jugs, the laundry containers and things like that, are more easily recyclable than the grocery bags. But there is the possibility of recycling that's going to be present. Some health concerns associated with that as we learn about more and more about what's going to be present within the plastics, and as we're using them. Again, most of the plastics have been invented within the last century. We don't know the long-term effects of that. We don't know the long-term breakdown of this. The health concern with these high-density polyethylenes is that they can release or basically leach out estrogen-mimicking chemicals when exposed to ultraviolet light. And so there's a possibility that chemicals that are put into the plastic as a result of the manufacturing can result in kind of harmful things to the body. The low-density polyethylene, basically same idea, but not higher density, not packed as tight. So the recycle code number 4, LDPE, these are used in kind of thinner plastic bags, and so you would see that in the bags that you would get to put your vegetables in, your produce in at a grocery store, oftentimes the clear plastic containers. And these low-density polyethylenes generally cannot be recycled. They can be reused, but in most cases they can't be recycled in a meaningful fashion. And so if we take a look at this, again, this is relatively new stuff. This is most of these plastics were invented in the 20th century, so invented roughly 100 years ago or less. Many of them much less than that. And so we're not sure the long-term effects of the plastic. We're not sure the long-term kind of breakdown process of the plastics. A number of studies have been done looking at this. And what they were able to see is that, if you take a look at a plastic bag over here, when exposed to ultraviolet light coming from sunlight, in essence, and oxygen and heat within the atmosphere, you can start to see these plastic bags break down. But the problem is they break down, but they don't decompose. They break down from large pieces of plastic into smaller pieces of plastic. But when you get them further and further away from the ultraviolet light within sunlight and oxygen, that process slows down. And so a plastic bag, sadly, on the surface of the ocean, may be able to kind of break down into smaller pieces of plastic, but then as it ends up getting, kind of submerged, it's going to become less likely to break down. And if it gets, into the sediment, it could be in that area for a long period of time. And if you take a look at the statistics, researching this talk, trying to come up with, how long it takes for a plastic bag to break down, there's no clear answer. The conditions vary greatly. Some say 10 to 20 years if it's exposed to sunlight. Others say, could be 100 years, 500 years. I've seen, as long as 1,000 years if it's buried and, kind of compacted within a landfill. But ultimately, what they're showing is even if these plastic bags are breaking down, the plastic components within them are not breaking down. They're not going to be broken down in their constituent parts. What's happening is that these large plastic bags, these large pieces of plastic, basically break down into what are referred to as microplastics. And so over here, megaplastics, use a lot of scientific terms for this. Basically, big plastics. This is the stuff that you're going to be able to see, in your house. You're going to be able to see it in a landfill. Sadly, you're going to be able to see this, on the beaches, on the shores, on the edges of rivers. But ultimately, what's going to happen is that as that breaks down, it basically goes from a large piece of plastic into a smaller piece of plastic. And so illustrated here on this slide, we're going to go from megaplastics to macroplastics to mesoplastics into microplastics. And so microplastics are little plastic particles that are smaller than about 5 millimeters in size. In many cases, much smaller to that. And so if we take a look at this, we are exposed, and a little bit disturbing to take a look at this, we're exposed to a large number of microplastics in our daily lives. You can find a fair number of microplastics that have leached out of the water bottles in our disposable water bottles. We've got microplastics within the air. We've got microplastics within the tap water. And then there was a WHO report, a World Health Organization report, that's shown that there is a fair amount of microplastics that are found in the drinking water in many areas throughout the world. To take this a step further, scientists have been able to determine that they've been able to find plastics in the deepest part of the oceans. They put a submersible down into the Marianas Trench, the deepest part of the ocean, and they can find plastic debris down there. Explorers and scientists have gone up to the height of Mount Everest, top of Mount Everest, the highest mountain in the world. They're finding microplastics are going to be present there. And more we're seeing that these microplastics are being found within organisms, especially those that are living in aquatic areas. In this case, this is taking a look at a mussel, so like a clam, that is a filter feeder, drawing in, kind of food from its surrounding area. But those plastics aren't going to be able to be digested. In many cases, they're going to be incorporated into the bodies. Somewhat more disturbing to that, and these are two 2022 articles, first coming out in May, the second, a little bit of a early release, but a July 2022 article showing that they've been able to identify plastic particles, these microplastics, within human blood as well as within human lung tissue. And so these plastics that are out there in the environment are now being found within the cells of lots of different organisms, but we're also finding it within human blood cells and human lung tissues. And I expect as we start to look at this more and more going forward, we're going to find that these microplastics are going to be present. Still not a huge amount of understanding about what the presence of these microplastics are going to be doing within the body, but probably not going to be good. Microplastics have the ability to carry bacteria with them. Microplastics, as we saw with the high-density polyethylenes, have chemicals in them that will mimic estrogens, mimic hormones that could have pretty dramatic effects on the body. And so because of that, there is a concern that's going to be present. Now, the hope is that ultimately we're going to be able to evolve the plastic recycling supply chain in some way, that we get more of the plastics back into this reuse process, and so recycling it in that way, but then going through a process and going through either mechanical recycling or chemical recycling, be able to take many of the plastics that are not currently being recycled and break them down into their individual subunits and kind of reform plastic from that. So be able to use less of the raw ingredients, the fossil fuel ingredients for the creation of plastics, and minimize the plastic that is being disposed of, that is going into the landfills and going into the oceans for extended periods of time. And so then the ethical dilemma in science then is, how do you balance the immediate benefits of a single-use plastic bag? You go into the store, you get a whole bunch of different items that you want to purchase, and they give you a cart to kind of drag your materials around in the store. Even if you get one of those little baskets, they give you something to carry your stuff. But then to leave the store, unless you remember to bring in your, a box or bring in a reusable bag, you're going to have to get a bag from them, and they're going to give you the easiest thing that they've got, the most inexpensive thing that is going to do the job. And for a long time, that was going to be these single-use plastic bags. You just shove a bunch of things into the bag. It's relatively strong. It is going to carry the things out to your car, bring them back to your home. But then you've got this plastic bag, and you shove it in a corner, maybe put trash in it, things like that. But as we've seen, it takes a very, very long time for those plastic bags to break down. And when they're breaking down, they're also forming these microplastics that could have detrimental effects on individuals. And so how do we balance those immediate needs of needing to carry something out of a store versus the long-term environmental impact, the environmental costs associated with this? We take a look at it, it's convenient to be able to have a bag to take things home, but then that bag that you use for a few minutes to a few hours is then going to sit in a landfill or sit in the ocean for 10, 100, 1,000 years, and even then, it could end up causing these microplastics to form, causing a detrimental effect. And again, I'm assuming a detrimental effect, but it's going to cause some type of effect as it accumulates in living tissues, whether we're talking about human tissues or tissues of plants and animals within the environment. So that's what's going on with these plastic bag bans. And so it's an issue that we need to think about and try to figure out what is the best way forward. So hopefully you enjoyed this. Thank you and have a great week.